Hi guys, good morning. How you guys doing today? Okay, so today we're going to do example 5.7, your textbook. Okay, so let's go ahead and get to it. So example 5.7. Alright, so this will be the last example in chapter 5, and then after that we'll move on to the different chapters. So this is our last network model. And so the files we'll need are just these two. Okay, the example 5.7 Word document has the steps and the formulas. You can refer to that. And the Excel template is the other one. The flight scheduling. So it looks like that. Alright, so let me introduce the exercise here. Okay, so this is just the PDF that I put the older version of the textbook, so we can refer to that. In that version, they have the same exercise, but it's a different example. It's 5.8 on here, but for us it's 5.7 in the 5th edition that we're using. But this is the same one. So it's the scheduling flights at Tri-City Airlines. Okay, so Tri-City Airlines flies several daily commuter flights to and from New York City, Washington, D.C., and Boston. The company has been flying a fixed daily schedule of flights, but it's now deciding whether to change the schedule. Each potential flight has an estimated net revenue based on the typical number of passengers per flight. The company owns 4 airplanes and it does not want to buy any more. So we're going to stick with the 4 airplanes. And there's a fixed cost of $1,500 per plane per day that flies any flights, and a plane that is not used does not incur this cost. Okay? There's no required delay time on the ground, and so that simplifies it. So if the flight arrives in Boston at 10, it can leave immediately at 10. Obviously, that's not realistic, but it's a simplification, and it's easier to model. So it's in military time, and any plane that arrives in the city after the last flight has 2 options that we got to figure out. And so it can just sit there overnight, or at a cost of $500, it can fly to another city and be prepared to fly a flight from that new city. So it either stays in the city it lands for the last flight of the day, or it can be flown to a new city, one of the 3, and then it can be ready for takeoff in the morning. Okay, so what we want to do is maximize net profit per day, which is basically the revenues from all the flights. So we got to pay for the cost of flying the planes, minus any overnight costs if they do that. Okay, so we want to develop a network model that we've been doing in chapter 5. Yeah, so the scheduling of the airplane flights with the 4 available aircraft, and we want to maximize the net profits from this flight, from this project. Okay, so the flight scheduling Excel document shows what we're doing. There's a lot of stuff on here, but it won't take too long. And so we can just start going through and coloring the inputs and objectives and decision variables and put the constraints in. Okay, so again, we'll do example 5.7. This is the flight schedule Excel file. Okay, so this shows how many planes are owned, which is 4. And the fixed cost per plane, all these numbers are in hundreds, so that's 1,500. And the overnight cost is 500. So those are all inputs. So we can just start by coloring that little group, the light blue color for inputs. Okay, and all of this flight information is basically an input because we have to use it to develop our model. And so this whole area that shows all the flight numbers from the origin to destination, the time, and the net revenue, that's all inputs, so we can color this whole block light blue. Okay, so basically A10 to F32. Okay, so again, this shows all the options that we can choose from to maximize our revenue. So these are the flight numbers. And for example, this one goes from Boston to New York. That leaves at 8 in the morning and arrives at 9, and the revenue is 2,500. This one leaves from New York, goes to DC, that leaves at 1 o'clock, arrives at 2:30, and that's 1,800 in revenue. So these are all the options with the departures and arrivals in military time, and the net revenue is in hundreds. Alright, so again, we only have 4 planes, so we have to use those planes to maximize our revenue given these possible options. Okay, so we're still setting up the model with the appropriate colors, and so up down here we have the network formulation, so the flight arcs, and so one of the things we're deciding is which planes or which flights to choose, and that's under the flight flow area. And so starting here, and looks like D37. This is going to be a decision variable range, so we can color this area. All right, let's just put a 1 in here for now. And we can copy that 1 just to put any values in the decision variable range for now. So just drag the 1 down. Okay, so you've got a 1 from D37 to D59. And that's one of our decision variable ranges, so we can color that the light red color. Okay, then if you scroll down a little bit, you'll see the ground arc. We also have to decide the ground flow, so which planes to, so you can see that we're deciding what we do with the planes during the downtime, and so these are all options if we want to keep the plane on the ground in Boston from 8 to 8:30. We can do that, but we have to specify it so the model knows where that plane is. So this is like just keeping account of where the planes are. All right, so put a 1 in D63, and let's copy that 1 down the ground flow column in column D, because this is going to be another decision variable option for Solver to figure out. Okay, so you just want to warn in D63 all the way down to D134. And we can color that whole range the light red color because that's another decision variable range. All right, if you scroll down a little bit more, that we have one more thing to decide on, or one more decision variable range, which is the overnight flow. So this is what we do overnight. Right, we either fly the plane from one city to another. We can fly from Boston to New York, or we can just leave the plane in the same city that it was in at no cost. So we have to account for the 4 planes, what we're going to do with those planes overnight. All right, so just put a 1 in E138. And same deal here, you can drag that down to the overnight flow column. So just drag the 1 down to so you want a 1 in E138 to E146. And that's our final decision variable range. So let's color that light red color as well. Alright, and then finally, before we start doing range names, we need to identify our objective, which is to maximize net profit. So B156 is our objective cell. That's the highlight yellow color. Okay, so basically we're deciding, we're maximizing net revenue by deciding the flight flows, the ground flows, and the overnight flows subject to the constraints and the cost that we gotta pay for the plane. Okay, so now we gotta set up or identify our range names. And so there's quite a few, but they're all kind of grouped together. I don't think we need any for the inputs range, so we can scroll down. Okay, it's probably easier just, even if we don't need it, if it's kind of next to one of the other ones, it's easier just to make them, just in case. And so we can make a range name for flight origin, flight destination, flight net revenue, and flight flow, all together pretty easily. So just select this range. Okay, so you want to select A36 to D59. Alright, and then remember our to make a range name formula is create from selection. Okay, you can see that there's, Excel doesn't know what we want to do, so we have to specify that we want the range name to be from the top row name, not the left column. So it doesn't know. So we have to specify that we want the top row for it to be the range names for flight origin, flight destination, flight net revenue, and flight flow. So uncheck the left column and only have top row, right? Because it's the column, not the rows that we want named. Okay, you can make a range name for flight capacity. There's nothing in it yet, but there's going to be. So just select this range manually with the keyboard or the mouse. Alright, select F36 to F59 and make a range name for that. Okay, you also want a range name for this constraint over here, the flow bounds constraint. So you want one for net outflow and also required. Okay, so first select I36 to I111, and you can make a range name for that range. Okay, and then you want to select K36 to K111 and make a range name for that. Alright, then let's scroll down and get the range names below. Alright, so we can just make one for the ground origin, the ground destination, the ground flow, or sorry, the ground cost and the ground flow, all together, because it's probably easier just to do that. So select this range. So, all from A62 to D134. Alright, and so again, we have, if Excel's not sure what we want to do, we have to make sure that we tell it. So, uncheck the left column, and we want range names for the 4 top rows going down the column. Alright, let's scroll down to the overnight. Alright, so we might as well do these ones. Okay, so we got a bunch of range names, but it'll make things a lot smoother when we do the equations. So let's just do overnight cost, overnight destination, fixed cost, overnight cost, and overnight flow, all in a group of range names at the same time. Okay, so you can select that range, A137 to E146, and make those range names. Alright, so again, uncheck the left column. We want the range names to be our top rows going down the columns. Alright, so we got a few more. You can make one for number used and number owned. It's just a single cell for each, but it'll make things easier. Alright, so I just made a range name, so D150 is number used, and D150 is number owned. Alright, and finally we can get the group of monetary values, and that'll be our last group of range names. Okay, so you can select A153 to B156. Alright, and left column is right for those ones. Alright, so we made a bunch of ways names just because I thought it'd be easier when we're doing the equations later. And so here's the list that I made. Would anybody like to see any of these ranges again? I guess we got kind of a bunch, but okay. Everyone's got the range names? Okay. I guess let's move on to step one. And so this is a big formula for step one. You're going to put it in I-37. Okay, and let me show you the formula just so we're clear what we're doing. Alright, so we're going to type in this big formula here. And I'll explain it after we type it in, but I'll do it on the screen, but if you have it as a reference, it's probably easier to look at that. But it's this big formula all together, and it's right there under step one. So let's start doing that. Alright, so here we go. Okay, so I'm still typing in, but make sure so it's all of what comes out of the flow origins minus what goes into. So it's the net. And so make sure you see that at this point there's a minus and then another parenthesis because we want to subtract the sum f of all the things that go into the destination. Okay, and you got that, the double parenthesis at the end. So let me hit enter, and I'll go through this again. Let me just make sure it works. Okay, so here's our formula that I put in. I think it's right. So it's equal to sum if flight origin H37 flight flow minus sum if ground origin H37 ground flow plus sum if overnight origin H37 overnight flow. And then right here we have a minus, a parenthesis, and sum if flight destination H37 where am I? Flight flow plus sum if ground destination H37 ground flow, and then plus sum if overnight destination H37 overnight flow. So it's long, but it's basically the sum if what goes out of the origin. So the sum if the origin flows minus the sum if the destination flows. So you should see that you have like flight flow, ground flow, overnight flow minus flight flow, ground flow, overnight flow. And we're just getting the one node for now. Once we get the formula right, we can drag it down. So let me hit enter again. Alright, so there, I made the formula box a little bit bigger just in case. So any problems with this formula? Is it still typing it in? Okay. So if you got that formula, we're going to just copy it down the whole net outflow column. So if you got the formula right, you can just double click the bottom right corner. Okay, and you should apply that same formula all the way from I. Okay, from all the way from I-37 down to I-111. Okay, so it should be the same formula, but it should capture the appropriate node that it comes from. So this last one should go to H111, so it's the same formula, but it gets the appropriate H indicated in the H column. Okay, so everybody good on that? Do we need anything again or any help on that? Okay, let's go to step 2. And step 2 is just to put a 0 in K37 and copy it down the K column. Okay, so all of the net outflows have to be 0 after the solver runs, so I'm just going to specify that here, just put a 0 starting in K37. And you can double click the bottom right corner just to apply a 0 in that whole range. Alright, so you should have a 0 in K37 all the way to K111. Alright, so step 3 is to put a 1 in F37, and then copy it down the F column. So put a 1 here, and you can just double click the bottom right corner to apply a 1 in this range. Okay, so you should have a 1 in F37 to F59, and that should be your flight capacity range. Okay, so you can see that all the flight flows have to be less than or equal to 1 because we can either choose the flow, but we can't send more than one plane on the same route. So you can only put, okay, so you can only send one plane on the same route, and so either you can choose the flight flow, or you don't, but you can't send more than one because it's only one flight per route. So that's what that constraint says. Okay, step 4 is instead of B150, okay, in B150, put the formula you see for step 4, which is equal to sum of overnight flow. Alright, equals sum overnight flow. Okay, so when this is run, this will show that how many planes we use. So we can't use more than 4. Alright, we can't keep more than 4 planes on the ground, which will account for that. Okay, so now for the monetary values, this is step 5. So you can put there's the three formulas in step 5 that go in B153, B154, and B155. And you can see those on the document. So starting here, put that first formula in. Okay, so equals sum product flight net revenue, comma, flight flow. Alright, so that shows that our revenue is the revenue we get per flight. And then if we choose the flight, we get the revenue. If we don't, we do not. So it's the sum product of this range. Okay, the next one in B154. Equals sum product of C138 to C146, comma, overnight flow. Okay, and so if we choose the overnight flow, then we got to pay the fixed cost. So this is the sum product for that range. And the last one for overnight costs is B155. Okay, equals sum product D138 to D146, comma, overnight flow. Okay, so this is the cost for overnight if we choose to do so. So if we fly one or more of the planes to a different city in the middle of the night, we're going to pay that $500. Okay, and then let's enter this in step 6. Let's calculate our objective, which is net profit that we're going to maximize. So in step 6, just specify our profit, which is equal to. Alright, so equals D, 153 minus D 154 minus B 155. Okay, and that just shows that our profit is the revenue minus the fixed cost and minus the overnight cost. So our revenue is how much, or our profit is how much we make in revenue minus the two costs. Alright, everybody good so far? Okay. Step 7 is let's make a reference to flight net revenue in cell C37 and copy it down the C column. Okay, so we just have to loop in the revenues from the inputs range. Alright, so these are all the revenues, and the flights on the flow area are listed in order. So if we just say that the first one equals this, and then just copy it down, it should work. So just start in C37, and this is equal to F10. Okay, and then you can just drag that reference down. In Excel will go down and give you the appropriate flight net revenue for the flights that we have listed. Okay, so just drag that reference down from C37 to C59, and you can see that it should just be the same numbers as you see here, because all the revenues just need to go next to the flight flow so we can do the sum product. Alright, so all of these numbers here should be right here in this range for the flight net revenue. Okay, step 8 is let's put a 0 in ground cost in cell C63 and copy it down to C column. Okay, so the ground cost, it doesn't cost anything to leave this here on the ground, but we have to specify it so we can account for the plan. So just put a 0 here in C63. And you can double click the bottom right corner to apply the zeros. So you got 0 in C63 to C134. Okay, so can you do the step 7 again, the input for cell C37? Yeah. Okay, so all we did here is link in the revenues from the input table above. So starting with C37, that's equal to F10. Okay, and so you can see that this flight, the 1357 from Boston, New York, from 8 to 9. That's listed right here, simplified, flight from Boston 8 to New York 9. And so we know that gives us a revenue of 25. Alright, and so all of these flight numbers and origins and destinations, departures, arrivals, and revenues are listed here in a simplified form. So this shows all those options, and we're just copying the revenue from each respective option. So if you just put equals F10 here, and then just grab the bottom right corner and drag it down. Alright, then that should go down. So this should be equals F10, this should be equals F11, and this should go down that input F column to give you the appropriate revenue for all of the flight options. Alright, so the last one should be equals F32 to double check, and that's Washington to Boston, which is that one that gives you 50. So all the numbers you see in the F column, F10 to F32 should be down there. Okay, did that work? Okay, you're welcome. Okay, step 9 is just to put equals D, $5 into C138 and copy it down because the fixed cost is always the same. So in C138, let's just type in. Alright, so equals $D, $5, and so that's the reference to the fixed cost input. See, the fixed cost is always 1,500. Alright, and then just double click the bottom right corner to have equals $D, $5 in this whole range. Okay, so you should have a 15, which means 1,500, and C138 to C146. Alright, and the final step before we do the solver is step 10. And so what you gotta do is put a 0 or a 5 in the appropriate option for overnight costs. And so if you don't fly the plane to a different city, there's no cost. But if you do, it's 5 for 500. Okay, so we gotta do this manually, which just means if you see that the plane goes to a different city overnight, put it in a 5. If it stays in the same city, just put it in a 0. Okay, so you can see Boston to Boston, there's no cost on that, that's a 0. If you fly from Boston to New York overnight, that's a cost of 500, so put it in a 5. If you fly from Boston to DC overnight, that's also 500, put it in a 5. If we fly from New York to Boston overnight, that's 500, 5. If it stays in New York overnight, there's no cost on that, that's a 0. If you fly from New York to DC overnight, that's a 5. If you fly from DC to Boston overnight, that's a 5. If you fly from DC to New York overnight, that's a 5. And if you just stay in DC, that's a 0. Okay, so that's what we did for the overnight cost. And then finally, just specify that the number you use for total planes can't exceed the number you have, which is 4. So just put a 4 in D150. Okay. So the next step is just to run solver and to maximize net revenue by choosing all the flows and staying in the constraints. Anything else we need again before I do the solver? Okay, well let's run the solver and see what points we should choose to maximize our revenue. All right, so if we have the option data solver. Okay, our objective is to maximize the revenue, so let's go select that cell. B156. All right, we're maximizing that, so you can leave that there. And we have the three flow ranges, which we have to specify separately as the decision variable ranges. All right, so since they're big ranges, maybe I'll just type them in to indicate the range name. So the first is the ground flow, and the range name is going to be ground underscore flow. All right, so that's for that one. Then put in a comma. And we also want to specify that we want to change the overnight flow, so you can just type in that range name, overnight underscore flow. Okay, and then comma, and we got one more that we can type in. Scroll down. Oh. So obviously we will put the flight flow as well. So that was the first one I made. But you can specify flight underscore flow. All right, so you can type them in just like that if you made the range names, because Excel knows what ranges you're referring to if you identify the exact name. So if it doesn't give you any errors, that means you got the ranges right. Okay, so we have some constraints. Let's specify those with the add button here. Okay, so we can specify that the flight flow is going to be less than or equal to the flight capacity. And again, because these are big ranges, I'm just going to type them in for easier. I think it's a little bit easier if you have the range name. So let's specify that flight flow has got to be less than or equal to flight capacity with the appropriate range names with the underscores. All right, so right there, flight flow is less than or equal to flight capacity. Okay, so we have a few more constraints. Click on the add button if you can do this. Okay, so we can specify this constraint where net outflow equals required. And again, you can just type it in, assuming you made the range name. So net underscore flow equals required. Sorry, net underscore outflow. Okay, net underscore outflow equals required. Alright, so there's a couple more constraints, and we can solve this. Hit the add button. We can get it this far. Okay, I think the last constraint is just the constraint on planes, and we can't use more planes than we have of the 4. And so we can just specify, let's just select these with the mouse because they're right there. It's just one cell each, so we want to say that number used is less than or equal to number owned. Alright, so B150 is less than or equal to E150. And that should come out, the number used is less than or equal to number owned. Okay, and then just change that solving method to simplex LP for linear programming, and I think this is all we need for the solver. Okay, so your objective is net profit. You want to maximize this profit. You're changing ground flow, overnight flow, and flight flow in no particular order, but they got to be with commas for those red decision variable ranges. The 3 constraints are flight flow is less than or equal to flight capacity, net outflow equals required, and number used is less than or equal to number owned. And then the solving method is always going to be simplex. Alright, so we can solve this. Okay, so I got a net profit of 396, and this is in hundreds, so this is going to be about 40,000. It's 39,600 because everything is in hundreds. So we get 396, which means 39,600. Alright, and so you can see that we used exactly 4 planes. Okay, for the overnight flow options, we did not pay to send the planes overnight to a new destination, probably because that was expensive. So it looks like we kept 2 planes in Boston overnight, and the other 2 planes we kept in DC overnight, and then just had those ready for the next morning. Okay, so this is just one day. This is what they should do, assuming everything is accurate, cost-wise and revenue-wise, to maximize revenue for a given day. Alright, and then if you look here to the flight flows, these are the flights we chose to do. And so if there's a 1, we chose the flight with the revenue, and if there's a 0, we didn't do that flight. Or we didn't have enough planes, so we chose the flights that satisfy our constraints that give us the highest revenue. Okay, and then how many flights were flown? You can see that just by summing the D column if you want. And so in D60, you can just say equals. Okay, equals the sum of the flight flow, which is the sum of all the flights that we chose. And so this is the total number of flights that this company this airline company ran in the day to maximize their profit. So equals sum flight flow. Okay, so it looks like we were able to do 17 flights, satisfy all the constraints, and that gave us that revenue of $39,600. Okay, questions on that one? We're almost done with this one. Okay, so before we close out for today, I know that a lot of you don't have Solver or don't have the full version of Excel, which is fine. I mean, we can always work with what we got. But I do want to, I think, so we're not going to use Solver every time, but we're going to start using, especially in chapter 14 or whatever it is, the next chapter, we're going to use the data analysis option. And so I want to see, I think, even if you're using like the online version or Google Sheets, that you should have it. And so what I want to see, just if you guys are still there, and can check if you have the data analysis option. Okay, and you have to check it like we did for Solver. So if you click on data and you see data analysis, that means you have it. And so if you're able to do this, let me just show you how you check data analysis, or I guess load data analysis. So try to do this if you can. If you're using, even if you're using like the online Excel version, I think it still works. Okay, so you go to File, and then Options. Okay, and then Add-ins. Okay, and then down there where it says Manage Excel Add-ins, click on the Go button. All right, and hopefully some of you have an option for the Analysis Toolpack. Okay, and if you do have that option, just check it and hit OK. And I think that option is available even on the online version, the free version. Okay, and so if that was able to work on whatever version you're using, then under Data, or it might be a little bit different on a Mac version, but on the Data tab for Windows, you should see the Data Analysis option. We're not going to use this today, but I just wanted to see if you guys were able to use it. And so were you guys able to get that? Like, okay. And so if you were not able to, just write something in the chat or turn on your volume and let me know. Because I know that some of you, all right, so just, can you load data analysis with Excel Online is what I'm asking? Is data validation the same? I'm not sure, but so let me see. Alright, so when you click on data analysis, it should give you a bunch of analysis tools like that. So if you click on data validation, does it do that? Okay, well, I can't look at your computers right now, but, alright, so I just wanted to see if you can load data analysis, because we're going to use it for the next couple weeks. And so I think even if you don't have Solver, but you do have data analysis, you should be able to do 100% of the exercises going forward if you can just do data analysis. And so, okay. So we're done with example 5.7, and so when he's done with that, this is, alright, so when you're done with example 5.7, you can put it there, the 5.7 one we just did, and just, if you couldn't do the solver part, that's okay, just put as much as you can do. And so example 5.5 and 5.6, which we did Monday, and example 5.7, which we did today, are both due next Monday. Okay, and then next Monday, we're going to do start doing some examples in chapter 14, which we're not going to need the solver for, but we're going to need the data analysis. So, if you're good with example 5.7 and data analysis, then, you're good to go for today. And, always stay safe and have a good weekend, and I'll see you Monday at 7:40. If you have any questions about the data analysis, please either ask them or post them to the chat so I can try to help you get those. If you have the online version, I just wanted to know if you could get the data analysis.